Okay, let's take a look at this. This is, I brought up one of your attempts. And I'm hiding the top part so you can't see any names. So I'm not putting your grade out here. Okay, second side of a triangular deck. Okay, triangular deck. Second side is 4 feet longer than the shortest side. And the third side is 4 feet shorter than twice the length of the shortest side. So they're all being put in terms of the shortest side. Let's say this side is my shortest side, x. Then the second side is 4 feet longer. So 4 feet longer would be x plus 4. Now this other side, and a third side that is 4 feet shorter than twice the length of the shortest side. So 2 times the shortest minus 4. So 2x minus 4. Now it says the perimeter is 80 feet, so that's all the way around. So we got 2x minus 4 plus x plus 4 plus x equals, what did I say, 80? 80. Okay. X plus x plus x is 4x. Negative 4 plus 4 cancels. Divide both sides by 4. And you get x equal to 20. So this side would be 20. This is x plus 4, so this would be 24. This would be 2 times x. 2 times 20 is 40, minus 4 is 36. And that's where they get to 20, 24, and 36. I hate word problems. So I have to think about them. When Fritz drives to work, his trip takes 36 minutes, but when he takes a train, it takes 20 minutes. Find the distance Fritz travels to work. If the train travels an average of 48 minutes. Okay, so there looks like we got a drives to work his trip. So I assume a car and a train are going the same distance. That's what I'm reading. Sometimes he takes a car to work, sometimes he takes a train to work. When Fritz drives to work, his trip takes 36 minutes. So the t here would be 36. But when he takes a train, it takes 20 minutes. So the t here would be 20 minutes. Find the distance Fritz travels to work if the train travels an average of 48 miles per hour faster than his driving. So if r is our variable, so that's speed, then an average of 48 miles per hour faster, this would be r plus 48 is our speed. Assume the train travels the same distance as the car. Okay. Let me think now. The distance is the same. So the distance of the car is going to equal to the distance of the train. Now distance is rate times time. So I'll leave this one as r. So I got time. So I got r times 36, or 36r for the car. Now for the train, distance is equal to r times t again. And so t is 20, and this is r. So I'll have 20 times r plus 48. Okay, so I got 36r is equal to 20r plus, let's see, 960. Take that over. We got 36r minus 20r is equal to 960. That gives us 16r is equal to 960. R is equal to 6. Okay, so 60? Yeah, 60. So that would be the car. Now the train then would go 48 miles per hour faster. 60 plus 48 is 108. Look at what they're actually asking for. Assume the train travels find a distance. So we want to find a distance, not r. So if I come up here, distance is equal to r times t. R for this we said was 60 times t, which is 36, but that's 36 minutes. Let me think about this. Okay, so what I've calculated. Miles per hour. This is 36. That'd be over. No, that's time. That's minutes. Okay, so let me think. 60 here is in I have to think about this. Let me see. 36 is my time. My rate is 60. This is 60 okay, 48 miles per hour. 36 minutes. Okay, so our time here in hours would be 36 over 60, and this would be 20 over 60. Now if I put these over 60, the 60s would just cancel anyway. So okay, we're fine there in terms of coming up with the R. Okay, so then I got this times that seems bizarre. This is miles per hour, and I want this in hours. So give us 36. Okay, well, okay, and that's how they get 36. I had to think about that. I started going down and thought I'd screwed it up because I hadn't considered these were in minutes. But worked out anyway. Okay, let me clear these off. And I got how much water should be added to 30 milliliters of 16% alcohol solution to reduce the concentration of 15%. Okay, so we got 30 milliliters of 16%. And I want how much water should be added. We'll come back to that. To reduce concentration of 15%. So we want to reduce that to 15%. This would be X, how much water. And there's no alcohol in it, so that would be 0%. Now this is our quantity here, and this is our quantity, so we got 30 plus X here. 4.8. That drops away. And distributed, I'm going to get my calculator. So 30 times 0.15, 4.5. And then 0.15 times x is 0.15x. Take the 4.5 over. And that gives us 0.3 equals 0.15x. Divide both sides by 0.15. I think 2. Minus 0.15. 0.3 divided by 0.15 gives us 2. And that's how they get 2 there. Okay, let's take a look at this one. how many gallons of a 70% antifreeze solution? X is our gallons. Must be mixed with a 70% antifreeze. Must be mixed with 90 gallons of 15%. 90 and 15% to get a mixture of 60%. So we got X plus 90 times 60%. Now this right here is a setup. So I won't actually finish that. I'll let you go on that. But that's how you do the setup.